Welcome back, ladies and gentlemen. This is the stoichiometry units. And what is stoichiometry? Stoichiometry is, let me see, the relationship between, the quantitative, using the number between parts of a chemical reactions, okay? Could be, so A plus B gives you C plus D. These are different compounds, so we can find the relationship between the reactants and the reactant and the product, or product and product. We can compare any two things on here, compare the relationship. And in order to compare the relationship, we have to have a balanced chemical equation. Okay, it has to be balanced. That is why we need to know how to balance it. It needs to be balanced. Let's say if this is 2, 4, 3, 5, for example. 2, 4, 3, 5. Okay, and these numbers in front are coefficients, and it tells us the number of moles. So this coefficient here, it tells us that that is 5 moles of D, right? 5 moles of D. So very similar to a cooking recipe here. So by now we should have done a lot of we did the waffle, and we did s'mores. And so we have equations already. We can compare the recipe, the ingredients to the products. And so here is a recipe, which is our equation, our chemical equation. So now you should have this packet in front of you. In order to do this, do this unit well, be able to do this calculations, you need to review some mole conversions first. Okay, go through and complete this page. Go back and review how to convert moles to grams, grams to mole, things like that. And really that's the key there, grams to mole, moles to gram. And so go through and do this. For example, let's do a couple here together. 3.7 moles of H2O. Okay, we want to get the mass of H2O. Then mole of H2O go down here, because that's what we start with up here. Okay, get that pattern. You definitely need that pattern for this unit. It is critical that you know how to do that. So mole of H2O go down there, then grams of H2O can go on top. Okay, 1 mole of H2O, get the mass of H2O is 18 grams. Then you multiply the top, because these two cancel out, and you're at the grams, and that's how you get the mass of H2O. Okay, very similar over here. Do that. Moles, grams to mole, we can do that. We should be able to do that now. Do that now here. Yeah, all these are pretty easy. Just practice on a couple, not the couple, the whole page here. Finish it, and then we'll move on. We'll move on, definitely. So pause it, finish this page before you move on, okay? Alright, today I will go, not today, but this lesson here, I will go over this first part, stoichiometry, mole to mole. Alright, we'll fill in the blank here. Before starting a stoichiometry problem, you must have a balanced chemical equation. Find a nicer pen here, I can write in that line. A balanced chemical reaction equation. The coefficients in a balanced reaction equation tells us the relationship between the number of moles. It tells us the moles, not the mass, okay? So it tells us the relationship between the moles of each substance in the reaction. It does not tell us the relationship between the number of, let's see, the number of grams. Yeah, grams. Mass. I thought it was mass, but it's actually the unit grams. Okay, it tells us the relationship between moles, not mass, not grams. Because 1 mole of water is not the same as 1 mole of salt. 1 mole of salt is not the same as 1 mole of magnesium. So here you have this nice equation there. Okay, the first thing you need to know is how to read this equation. Right here, 1 mole of magnesium, there's no number, so it's a 1, plus 2 moles of silver nitrate will produce 2 moles of silver and 1 mole of magnesium nitrate. Alright, so the coefficients are 1, 2, 2, 1. Okay, and so it says write all the possible mole ratios. So a mole ratio is a conversion factor. A mole ratio here is a conversion factor saying that in this equation, these values are equal. Okay? That means 1 mole of magnesium can potentially produce 2 moles of silver. 2 moles of silver nitrate can potentially produce magnesium nitrate here. 1 mole of magnesium nitrate, given we have enough magnesium, of course. Okay? Given we have enough of the other thing. So, mole ratio, you just pick 2. They already compared Ag and Mg, AgNO3 and Mg. So I can compare 2 moles of Ag to, let's see, Mg. 1 mole of Mg. That's a mole ratio. And if you flip it over, it's the same thing. Or 1 mole of Mg over 2 moles of Ag. So pick any 2 and write a mole ratio. Okay? And if I pick another one, here is 1 mole of Mg on top here. I can do that. And then pick something else. 2 moles of 1 mole of MgNO3. 1 mole MgNO3. Okay. So pick different combinations until you have 6 different combinations. Okay. I think these are actually two different combinations here. I think one. I don't know. Just get as much as you can. You can probably get more than that. And then we get Ag and AgNO3, 2 moles of Ag, 2 moles of Ag, and then 2 moles of AgNO3. Okay. So for these 2 moles of Ag and 2 moles of AgNO3, the ratio is 2 to 2. So therefore, you can also reduce it to 1 to 1. Okay. But usually I keep it like this because it's easier for me to relate. Like, oh, I got that from the equation. I got that from the equation. Okay. So you'll get used to this. Remember, in the past, we did the moles on top. 1 mole of something can also be grams of something, like 1 mole of H2O is certain grams of H2O. Okay, 1 mole of H2O can also be equal to something molecules of H2O. Okay, 6.02, which is 6.02 times 10 to the 23rd. Also, 1 mole of H2O gas can also be 22.4 liters of H2O. So there are a lot of things here, but these, we only deal with one substance, the same thing, which is all water. We don't have an equation to worry about. So when we deal with an equation, we can go 1 mole of something, 1 mole of H2O is compared to another mole, let's say mole of H2, in the equation of hydrogen plus oxygen gives you H2O. Okay? We have an equation. In order for us to use the mole over mole, we have to have an equation to compare 2 different things, 2 different compounds or molecules. Okay, but again, we have to start with a balanced chemical equation. So then 1 mole of H2O, it's actually 2 moles of H2O is 2 moles of H2. So it's actually 1 to 1 ratio there. Okay, so stoichiometry, you have to have an equation. And so from the equation, you get the mole ratios. Okay, the mass aren't the same though, and you'll see why later. So right now, we'll work on these problems here. Number 2. How many moles of AgNO3 will you need if you make 6 moles of MgNO3? Okay, 6 moles. So we start with 6 moles of that. I don't want to rewrite that, so I'm just going to be lazy here. I'm just going to draw a grid like that because it's right there already. 6 moles of MgNO3. Then immediately I put mole of MgNO3 down here. 2. Okay. So, what are we trying to get to? Let's always box or underline what we're trying to get to. Moles of AgNO3. How cool is that? So then mole, I can put another mole on top. Mole of AgNO3. Okay. And mole, let's look at the equation. Remember, the equation is right here. Equation's right there. Okay, let's not put my face over that one. Okay, there you go. So, what next, right? What next? What next is look at MgNO3. Well, how many moles is that? 1 mole. Let's compare these two. 1 mole is to 2 moles of AgNO3. And that's it. Right? If you think about it, 2 moles of AgNO3 will produce 1 mole of that. Silver nitrate will produce 1 mole of magnesium nitrate. So if we have 6 Oh, it's the other way around. Yeah, so we have, if we produce 6 moles of that, then we'll need double the amount of silver nitrate. So 6 times 2 here, multiply the top divided by the bottom like always, and you get 12 moles of AgNO3. Okay? So you always start with what you're given. Okay? And what you're given is pretty nice. Moles. So this first part is always just mole to mole, so 2 steps here. So all the way from 3 through number, there's 2 more on the back, number 11. That's mole to mole there. So let's go to number 11. I like to do a difficult one so that people don't say that I always just do the easy one. Number 11. This is a, oh my. Actually, number 10 is harder. This is combustion reaction number 11, CO2 plus H2O. That is our equation there. We need to balance that. Okay, I'll just go ahead and balance it, and then I'll go back and do number 10. 3 C's. 4, that'll make 8 H's. That gives us 6 oxygen right here on the right. 4 more oxygens right here. That's 10. So then I need a 5 there. So there's your balance equation for number 11. Okay. Number 10. Number 10 here is just what we just did. Double replacement reaction here. Alright. So F will come over. So obviously this is F is plus 3 because that's where that Cl is for. I got that 3 from. So keep that in mind. So you get Fe is plus 3. OH is minus 1. So then I'll put FeOH3 plus K is plus 1. Cl is minus 1. Which is KCl. And then you will balance these suckers. I have 3 OHs here. I have 1 OH there. I'll put a 3 there. I have 3 Ks there. I'll put a 3 there. That's a 3. Okay. It's an ugly 3, but still 3. And then that's 3 Cls. So the rest is 1. 3, 1, 1, 3. And so, what do? You start with 2 moles of potassium hydroxide. Which one is that? So, if it helps, circle the one that you're dealing with. 3 moles of potassium hydroxide. And how many moles of iron 3 hydroxide? So, how many moles of that will we produce? Notice it says react with iron 3 chloride. That's really extra information. You don't need that. So, make sure you can read and understand these things and understand what you're trying to find. Okay, it says, read the question again, how many moles of iron 3 hydroxide? So that's what I'm looking for. So we start with 2 moles of KOH, right? Then immediately mole of KOH go down here. And then moles of the other thing, which is what we're looking for. FeOH3 goes on top. And what is the relationship between them? Where do I get these numbers to go here? Where do I get the numbers to go there? We get it from the equation. That's the number of moles. Okay? You don't have to make up anything fancy. You don't have to try too hard, think too hard about that. You just go to the equation, copy it. How many moles of KOH? 3. How many moles of FeOH3? 1. Just the number in front. Okay? So now we got it. 2 times 1 divided by 3. 2 divided by 3 is 0.66666666. So 0.67 moles of FeOH. Oops. OH3. Okay? So there is your answer. It answers the question. How many moles of iron 3 hydroxide? And we went from mole of KOH to mole of iron 3 hydroxide. Okay, this will end this first part. The first part of this video. I know this is a little longer. Next time will be a lot shorter because I'll go one section at a time. So rewatch if you need. Try what you can. If you are struggling, you still need help, please come see me before school or after school on Mondays and Thursdays. Okay, goodbye.